Have you ever felt like you're veering toward the left edge of the runway during takeoff? It's not because you're a bad pilot. There's a reason your plane pulls left. Actually, there are four of them, and they're called left turning tendencies. Here's how they work and why you need right rudder during takeoff to correct them. Torque, which is the first left turning tendency we'll cover, comes from a pretty famous guy named Sir Isaac Newton. Newton's third law states that for every action there is an equal and opposite reaction. Most aircraft have engines that rotate clockwise when viewed from the cockpit. That's where torque comes into play. As you throttle up your engine for takeoff, the right turning direction of your engine and propeller forces the left side of your airplane down toward the runway. When the left side of the airplane is forced down onto the runway, the left tire has more friction with the ground than the right tire, making your aircraft want to turn left. P factor, which is also called asymmetric propeller loading, happens when the downward moving propeller blade takes a bigger bite of air than the upward moving blade. This happens in two scenarios. Your plane is flying at a high angle of attack. Takeoff and slow flight are good examples. And you're taking off in a tailwheel airplane. In both of these scenarios, your downward sweeping blade is at a much higher angle of attack than your upward sweeping blade. And with a higher AOA, the downward sweeping blade creates much more thrust, or lift, making your airplane want to yaw to the left. A spinning propeller is essentially a gyroscope, which is a spinning disc. That means it has the two properties of a gyroscope: rigidity in space and precession. We won't make this next part a physics lesson, but we will quickly and painlessly explain precession. Precession happens when you apply force to a spinning disc. Here's how it works. You apply a force to one point of the disc, and the effect of that force, the resultant force, is felt 90 degrees in the direction of rotation of the disc. For the most part, this only applies to tailwheel airplanes when they lift their tail off the runway during takeoff. As the tail comes up, a force is applied to the top of the propeller. And since the propeller is spinning clockwise, that force is felt 90 degrees to the right. That forward-moving force on the right side of the propeller creates a yawing motion to the left. Spiraling slipstream is the fourth and final left-turning tendency. It happens when your prop is moving fast and your plane is moving slow. And there's no better example of this than takeoff. During takeoff, air accelerated behind the prop, known as the slipstream, follows a corkscrew pattern. As it wraps itself around the fuselage of your plane, it hits the left side of your aircraft's tail, creating a yawing motion and making the aircraft yaw left. Spiraling slipstream is, of course, dependent on an aircraft's design, as well the phase of flight you're in, so it's hard to quantify how much effect it really has on your plane. Here are a few pictures to help you visualize it. Why you need so much right rudder. The four left-turning tendencies create the forces that make your airplane veer left during takeoff. Step on the right rudder to cancel them out, and you'll maintain a perfect center line throughout your takeoff roll.